your participation to the spreadsheet. In the spreadsheet, there's somebody wanting to participate. Okay, but I cannot see. Okay, so let me share one screen and okay. So have you thought to some model that you want to implement? Because remember that I would like also to have to try to implement your suggestion. If not, I can propose a couple of models. First one could be try to arrange for an environment where, I don't know, to model the growth of some trees. Then there may be a fire, and try to find the critical percentage of trees that so it is able to either have a fire that spreads all over the okay. Seretella is also reporting in the chat the link where you can register. Okay, thank you, Elena. And so let's start in this way. So assume that we now have some sliders, some button in order to grow a tree, a wood. When so Konstantin, you have to sign in the form in the page where there is also the material of the course, because this way I can just extract the participants from the spreadsheet. Okay, so suppose that so first of all we have a setup button and a slider that fixes the percentage of tree. So tree probability, say from 0 to 1 with some small increment. Okay, so this is for the moment our interface. So I can fix the tree probability, and then with the setup, I can populate the world. So this is rather simple. I can use just patches if I want. If you want, then we can also use say turtles if you want to have the shape of the tree. For the moment, let's start with patches. So to set up, first of all, I clear all. Then I ask patches. Say for the moment is simply if. So I have to extract a random number. Tommaso, you to sign in the spreadsheet which is accessible in the page that I re-put into the chat. Okay, so I have to extract a random number, say from 0 to 1. This is a random float 1. So random float extracts a random number from 0 to the amount specified here. So random float 1 is just show random float 1 is some random number. Each time it is a different one. So if this is less than 3 probability, this means that this is true with the probability equal to 3 probability. I so set p color green. For the moment, this is all. And now, according to this probability, I can have less or more percentage of my landscape covered by trees, by green patches. Okay, then we can say add a button, say start fire, which is a forever button. And so the idea is that now I choose one patch at random, or one green patches at random. I turn its color into red, and then as soon as far as there are some trees burning, I may suppose that it is red for one time step, and then it becomes brown, or because it is has finished to burn. So for the moment, let's start with start fire. To start fire, ask one off. So one off is another operator that takes a set and returns one random item of the set. One off patches, and if you want, with with p-color equal green. So you remember that this language is a set and list-oriented language. So patches is the set of all patches. With is a filter, so takes a set from one side and a reporter, something that returns true or false, on the other side. And for each element of this set, evaluates this reporter. If it is true, it is kept. If it is false, it is discarded. And so finally, I have another set with only those items that pass this test. One off takes a set and returns just an item. And so I can ask one of them to set p-color red. And that for the moment we can say just end here. So in this case, clearly we don't need a forever button, because otherwise, as you have seen, I finish converting all patches into red, and then I get an error because this will be empty. So this will be empty. Okay, so this is then start a fire, this one. We can do a propagate fire, and then we can call it from this one to propagate fire. I can ask patches with so this is I can proceed in two ways. I can either ask patches which are green and have a red neighbor to become red, or I can ask all red patches to ask neighboring ones to become red. These are two approaches, and we can try both. So ask patches with p-color equal green, and so I can take neighbors for, this is the set of the neighbors is in okay, American spelling. Neighbors 4 is the set of the 4 neighbors of each patch, and I can filter again this with the color equal red. So this I put the parentheses just to make it more readable. So neighbors 4 with the p color equal red is the set, can be empty, of neighbors of the patch I am addressing here, one of these. So I can next time I ask all of you to enter with your Unifi account, so I don't have to authorize each of you. Okay, and so let's continue. So this can be an empty set. In this case, I don't have to propagate fire. If it is not empty, I have to propagate fire. So the operator is any takes a set and returns true if this set is not empty, and false if it is empty. So this should be the condition. So p color equal green and at least one neighbors with p color equal red, set p color red, and so we can test the propagate fire. Let's put a button for the moment. Propagate fire. So, okay, you see that now the fire is propagating to neighbors like this. And okay, so now I can say make it automatic until the end, until there is some changes. So we can, if I can say, okay, something say set continue. I define a global variable continue, say globals continue. Propagate fire, set continue false, and but if there is a sum which is turning from green to red, set continue true. And so now in start fire or propagate fire, I can so start with continue equal to true. For instance, here set continue true, and while continue as far as continue is true, I call propagate fire. So now start fire should first set one of patches in the color to red, and then continue to propagate fire until nobody will change its color. So continue is false, and this should stop. So let's check. Start fire. Okay, you see that now. Probably if we go slower, we can see also the propagation of the fire. And okay, clearly now we can say check if now there is a critical probability. You see that here I can start a lot of fires, but none of them will propagate to all the neighbors. And if I increase the probability, now clearly we are still below the critical probability, but probably there is some, say, okay, here we are already near the critical probability, so that if I have more than this percentage of trees, I propagate the fire to a large fraction of my wood, not all of them, but some of these, more than 0.5%. More than half. So let's try to do a variant of this propagate fire in order to have a different approach. So I may call this propagate fire, say, okay, 1, just not to call it. So instead of asking patches with color equal to green to check if they have neighbors, I can do the opposite. I can ask patches with p color equal to red to do what? To ask neighbors for with p color equal to green to set p color red, set continue true. So the approach here is slightly different. Instead of ask green trees to check if they have some neighbors in fire, I ask trees in fire to propagate the fire to neighboring green trees. So let's see if it is working. No, start fire. Okay, so you see essentially we have the same result as before. This is just to show that we can so have different ways of implementing this code. Also, I can save it in the shared folder, so that let me check. This should be here, my drive. Let me see if it is the right one. Yes. Here, NetLogo 2000. Okay. Say forest fire. I don't know if there is another forest fire. Forest fire. Okay, so now you should be able to load it also if you want to test, to check, to play. So I said that maybe this interface is not what you like. So let's try to use turtles just to have real trees, and also to make practice with shapes. So I can use the turtle shapes editor to see if I have a tree already. Okay, I can use this one, for instance. So I have already a shape marked, so named the tree. So instead of ask patches to set p color green, I can create a turtle, and for patches this is a sprout one turtle. The language is the creator creates, so the observer creates turtles. Patches sprout some kind, like a plant, some turtles. A turtle hatches another turtle. So sprout one, set shape 3, set color green, and this should be essentially the same. Okay, so now I can have a more nice wood. And okay, now to start fire, I ask one of turtles with color equal to green, set color red, set continue true, while continue propagate fire, and this can be the same. To propagate fire, ask propagate fire, okay. So propagate fire, I ask turtles with the color equal to red, ask neighbors for neighbors for now is the set of 4 patches. So I can do a different things. I can ask turtles in radius 1. So I can do several things again. I can ask the patches, the neighboring patches, to ask the trees that are there. Okay, let's try to do the several things that we can do. So I can ask neighbor force, but not if any turtles here with maybe I can use this with the filter. So ask enable for with any turtles here with the color equal red. So the turtle, which is red, ask the 4 neighbors, those that have a turtle there, so on them, with the color equal to red. And so now, since I'm addressing neighbors, I have to ask turtles here, because clearly on a patch there can be more than one turtle. So I have the language say all turtles that are on a given patches to set color red, set continue true. So this is one of the options. Let me check. Maybe I can increase the density so I'm sure that a fire now something not working. So ask turtle with the color equal to red. Ask neighbors for with any turtles here with the color equal to green. Okay, now this should work. Okay. So this is one possibility. Then clearly there is also the other possibility. Let's try the second possibility is to ask patches with any now this is not really good for turtles. But we can do a different things. So let me comment or not use this and use this one, but I have to change. Instead of this, I can ask turtles with color equal to red. With turtles, I think it is much easier to ask those that are in fire to propagate fire. Then I can ask other turtles, not myself. This is just to introduce the other operator with in radius 1 with p color, with color equal to green. So let's spell this. Turtles in radius 1 are clearly all turtles in a given radius with respect to the one who is who is performing this action, including the turtle itself. So other means not myself, not really important here, but then I again use the filter color equal green, and then I can just copy these two instructions, set color red, set continue true, and this should be again equivalent to the other. Let's check. Okay, yes, it is working as before, so this can be eliminated. Okay, so again, this is several ways of implementing the same say problem with using patches, and in this case using turtles. Clearly they do not move, but this can be a way of say making the display more say interesting. Okay, now let's try with another problem. Clearly I'm still available to your suggestions, but we can do different things. For instance, we can try to model rabbit, say, and grass. So I suppose that you can use our patches in order to model grass that can, say, grow. And rabbit eat grass, and say, suppose that they have a certain energy. If they go down to zero with energy, they die. If energy is above, I don't know, a certain threshold, they can reproduce. They are more like amoeba than rabbits, because I don't want to introduce a sexual reproduction here, but we can try to implement these two things. So I can say, okay, I already saved this, so I destroyed the other one, but in any case, they're not very important. Oh no, I have not saved, so I can save it as forest fire turtles. Okay, so maybe we can start a new one. So again, I can have a button setup, and say in setup I can say make all the world covered by grass, clear all, ask patches set p color green, and then I can say create one turtle, create turtles one, set shape rabbit, if it is a rabbit. Let me check if a rabbit exists. So turtle shapes editor. So rabbit is not present. We can use a sheep just to have an herbivore. Sheep. Okay. Set the color. Only the face is colored, so I can say black. And say that turtles. Let me introduce a breed. Sheep. I think that the sheep is now a name in English that is always plural. So a sheep is a way of addressing just one of them. So create ship one, and I can also ship on energy and set energy 0.3, something like that. Say that when they have say more than 0.5 energy, they reproduce. Or we can also set a threshold here. Say, okay, let's put some interesting element. This can be grass growth rate, for instance. Let's say from 0 to 1 with some small increment. So we can now we have to decide what to do with this. Maybe we can instead of just having patches with a given 1 or 0 color, we can have a certain amount of grass and have a shape, or this can be okay. For the moment, just put this slide, and this can be reproduction energy. Say again some small value of increment, a maximum of 1. So let's suppose that this is the threshold at which sheep reproduce. So for the moment it is and let's see. So create sheep. Okay, then we have oh no, the color. So it is the color of the, not of the face, but the color of the body. Okay, so we have one sheep here in the sea of grass. Maybe we can make it patches on a variable called the grass, which can be say 0, 1. So ask patches set grass random float 1, and we can ask them to recolor in order to have since we have to every time we change the amount of grass we have to recolor, so we can make a procedure to recolor. We can set the p color scale color green according to the variable grass from 0 to 1. Let me see if this works. So now we have we scale the color of a given patch. We can inspect one of them. For instance, this one, which has color essentially black because it has very little amount of grass, while this say probably the white is the total amount of color. So maybe we can score from 0 to 2 so that we don't have a white, because grass goes from 0 to 1. So I expect that the patches with a color near to green has a grass near to 1, which is okay. And then we can make a go button. So maybe this growth rate 1 is really too much. We can stop at the 0.1, say. No. This one, say the maximum is 0.1. So that for the moment, let make only grass grow. So to go, ask patches, say set if grass less than 1, or maybe we can do the opposite in order to trigger them at 1. So ask grass plus grass growing rate. So I add this number to the variable grass. If grass greater than 1, grass equal 1. So I crop this value to a certain value, and then recolor. And for the moment, this could be our grow. Grass grow, growth, okay, growth rate. Set. Okay, check. Set, and I'm not able to remember this syntax for setting variable. Okay, now it should work. So if we make a grass grow without having nobody consuming it will grow until all of them will reach the value 1. But now we can also introduce sheeps. So ask sheep, well, maybe live. And to live, they say maybe they can wander, so move to one of neighbors 4. So they move to one of the neighbors. If grass, remember that if they can eat, say, a certain amount of grass, maybe we can establish how much. Well, maybe suppose that they eat all grass. So set energy plus grass, set grass to 0, and then maybe they can reproduce if energy greater than reproduction energy, they can hatch sheep 1. Maybe we can just say that the default shape is a sheep, so that we don't have to define a sheep. So set default sheep shape sheep, so that we don't have to to define every time the shape of the ship. So they can hatch a new ship, and they can give them half of the energy of myself divided by 2. So I cannot use, so the energy refers to the variable energy of the ship just created, just hatched. So I have now I am the ship which is hatching this new ship is can address to themselves with the word myself. Myself means who is asking you to do something. So energy of myself is the energy of the parent ship. I can divide it by 2, and then I can okay, I think this is enough, and then I halve, say, energy by 2. This is the caller, so half of the energy was given to the newborn ship. But now we have also to introduce the consumption. So they move and set energy minus energy consumption that we have to define. If energy less than 0, die. Otherwise, it can eat and then it can reproduce. And so maybe we need another slide which is energy consumption for each time step. So again, it is something between 0 and 1, probably much less than 1, otherwise everything dies. But okay, for the moment, we can use this 3. So let's see what happens. For the moment, nothing. Something is not default ship shape is not okay. Let's check because the default. So this is the NetLogo dictionary, and there is a default, but I don't remember the default. Set default shape. Set default. There is not for the breed. Breed. Okay, I have to pass the breed here. So to set the default shape. Sheep. Set default shape is just a single. Okay, now energy. Okay, we have to check. Okay, let's see. Go dies. Well, probably because energy consumption is too large. So set up. Okay, and now we have clearly we have this funny shape because they reproduce too much. So maybe we can decrease the grass growth rate. Okay, so they can, so first of all, they can invade, but then probably they have to wait for the grass to reproduce, and they may, say, disappear. And so first of all, I can save it so you can play. Save as grass sheep. Okay. Now we can say, for instance, add some plot. So we can say plot count ship, for instance, but this now it is not updated because unless you update the plot say from your script, it can be automatically updated. I mean, it means that if this command is executed, but only when the tick ticks. So for setup, we have to reset ticks, and from the go, we have to tick. And now the plot is automatically updated. And so go can be made forever. And so you see the extension. So maybe if we increase the growth rate, you can have, say, a stationary state, which is clearly with some noise. And now we can play, say, increasing the system size and so on. So this is one possibility. Clearly, we can also introduce predators, say wolf, that can, say, pursue ships. Ships can escape from wolves and so on. So this is a possibility. Let me know if you are interested. Remember that if we now go back to the dictionary, turtles can do a lot of things. You see that they have a lot of methods, much more than related to patches. And for instance, they can compute so they can calculate the number of other, say, for instance, wolves in a given radius, but not only in a given radius at a given, so you see, in radius and distance. Let me radius. So in radius, okay, this is a agent set. So, but not only in a given radius, but also in a cone at a certain distance, at a certain angle. And they can also compute the gradient. I don't remember the nickname for this, but in case, for instance, I have to remember how, but we can compute the direction in which there are less wolves, for instance, in order to escape in that direction. So if you are interested, let me know and we can elaborate. Otherwise, okay, we can leave for the moment this in this way, and I can propose a different game, always based on turtles. For instance, we could try to make a game in which you have a cannon, you can throw a projectile in some direction, and then you have to decide the inclination of the cannon and the amount of powder you have to put into the cannon in order, say, to overcome, say, I don't know, a given barrier and hit some ship, for instance, in the sea. maybe the ship can sail and so on. So if you agree, let's try to set up this game. So maybe the world can be made a little more rectangular, say like this. So suppose that we have a cannon here in this corner, in the left bottom corner. We have a sea here. In the sea there is a ship, and we have to calibrate the amount of powder and the inclination of cannon in order to hit the ship. And maybe we can make the ship to travel, so the game becomes more complex. So for the moment, we can start asking, say, a given amount of patches to become, say, yellow. This is the bank here, and the rest to become, say, blue. This is the sea. Maybe we can ask that our coordinate starts here, so it is easier to address them. And so the code could be to set up, say, clear all, then ask patches with y core equal to 0, set p color blue. Clearly this ask this with the py core. Okay, there are patches. Okay, so this is our C, and then maybe only if px core greater than say 5, if else, say, they are blue. Otherwise, they are, say, yellow. Set p color yellow. Okay, so now we have our bank here and our C here. Then let's put our target. Let's see if we have a ship somewhere. Okay, we can say make one. So suppose that this is the middle, so we can draw it say above the middle, for instance. So this could be our ship. This way maybe brown, and then we can make some this say white. This can be our ship, maybe not rotatable. Maybe we can do another like this. Okay. And so now we can, in the setup, ask one of patches with p color equal blue of, say, sprout 1, set the shape ship. Yeah, and this one. So okay, let me see. Okay, maybe it is too small, so set the size say 4. Okay, so now we have our ship here, and maybe the coordinates are too big. Maybe we can divide everything by 2. So, okay, now we can say set size, say 2. Okay. Too small, but okay. Now we can draw a cannon. I don't think it is available, so we have to set up new. We can say put say the wheel here. Oops. No. Okay. Like here. Maybe in the background, and another one, say, just to mark, this could be black in the background, these two in the background. Okay, now we have a nice, maybe too big, a nice wheel. This could be smaller, say like this, and this even smaller. Oh, I'm not able to use this tool. Okay. Okay, so, and then we need our cannon, which could be done, for instance, in this way. Then we adjust maybe gray. Could be a cannon. Maybe we can also add something like this. I don't know. We have not to snap to grid, so we can okay, let's try to arrange this. Okay, suppose that this is a cannon. Maybe we can make something better next time. For the moment. Okay, so this is our cannon that can be rotated. Remember that the heading is in the upper direction, so we have to adjust then this. Okay, cannon. Okay. I can save it so you can, if you want, download. I think that there is already another cannon, so I call it cannon ship. Okay, and so I also ask patch, say x equal to 2 and 0 to sprout. Maybe we have to use breeds, otherwise it is difficult. So breed sheep. I don't remember if no sheep. Sheep. Breed cannons. Cannon. So this sprout ships 1, ships, not shops, and here sprout cannons 1, set shape cannon, set size 2, and maybe set heading 0. Okay, let me see what happens. Cannon. Okay, maybe now we can place it a bit higher. So set the Y core, say 1. Okay. So now we have our cannon and our ship somewhere. Maybe also the ship we can set Y core. Probably 1 is too much. Okay, so 0.5 should be enough. Okay. Okay, so now we are ready. Now we can say make a slider to say cannon angle from say minimum say minus 90 to 90 degrees, and we can make a button active so that we can ask this cannon to take this cannon angle. So to aim, ask cannons. This is the advantage of using breads, so that I can collectively ask all cannons. I have just one, but so set the heading cannon angle, and so now with this I can maybe from 45 to 55 to minus 45 to 45, because this is really too much, but this is a problem of the person who changes the angle of the cannon. Okay, so this is almost all in the sense that we just miss the command, the most important part, say command to fire. So into fire we can say ask the cannon to hatch a ball, and then ask the ball to go on until something happens. So to fire we can ask cannons hatch balls 1. Clearly we have to use another breed. Balls ball, and clearly the set the shape circle, set I don't know, size probably 0.5 or something like it. Set the color I don't know, red, and let's see, probably we have now to make some movement of this ball, but set up fire. Okay, you see that the fire is created in the middle of our cannon. So maybe we can ask the ball to have the same heading of the cannon. Set the heading of myself, so that now he can move. Maybe 0.5 is too much, say 0.3. It can move forward some 0.3, let's see. Okay, you see that we can say increase a bit. So maybe forward 0.5 could be, let's see. Okay, you see that 0.5 is a good quantity. So we can say set up fire. Okay, maybe the cannon has to have a color fixed. So set shape cannon, set the color gray, so it doesn't change the color every time. Okay, so let me come back. So set up. Okay, now the ball is in the right position. If we change the angle, the ball always in the right position. I use the fact that the cannon has its own heading, so I made the ball with the same heading direction as the cannon, so moving of a certain amount, it goes in the right position. Then we have to ask the ball to make a certain trajectory. Clearly, we have also to set up the initial speed, which is, say, the amount of powder. So we can make another powder like this, say from 0 to 100, I don't know which is. So this is the amount of powder to be put into the cannon. And so maybe balls on now I think that it is much easier to compute the trajectory using the XY coordinates instead of a heading, because otherwise we have to turn the heading, but since it is relative, it is difficult to turn it in the right amount. So suppose that the balls have a position X, a position Y, Vx and Vy. I use X and Y because instead of X core, Y core, because in this way it is simpler to check if the balls goes outside, for instance here, outside the world, because I cannot set the coordinates of something outside the world, but it may happen that X and Y goes outside, so I can say use it to stop instead of having some error. Okay, now we have to set up the Vx and Vi according to the direction. So I can ask the ball at the beginning to turn its heading of 90 degree, right 90, so that if I ask them pen down forward, I don't know, 3, this should exit in the right direction. So You see, this is just for checking, just for checking that in this way the heading now is in the right direction. And so I can set Vx. Remember that the 0 is in the top, so Vx should be the this angle, this heading now is in the angle with respect to the vertical direction. So the velocity in the x direction is the sinus of heading, and the y direction is the cosinus of the heading. Set x core, set y core, and in order to check we can again move the ball according to Vx and Vy. So set xy Vx times x core plus Vx times 3, y core plus y times 3, just to check if the direction is the right one. So set up, aim, fire. Okay, it is in the right direction. Clearly, I don't want this one. And now fire has to ask the ball to make a trajectory. So trajectory. Maybe we can ask. So this is for preparing everything, and then we can ask balls. We have just one. Do trajectory. And then probably we have to stop if something happens. So to do trajectory, maybe we can have some globals dt, which is the amount for integrating the equation of motion. So set dt 0.01. Okay, so the idea here is quite simple. We can advance the x and y according to the Vx and y, change Vx and y according to the gravity, and check if something goes wrong. So either we can hit the C, we can exit here, we can also exit here, but we can also hit the ship. So to do trajectory, set x plus Vx times dt. Set y plus Vy times dt. Set Vy minus a certain g that we can define times dt, which is the gravity. And clearly, maybe we can define g globally. So maybe you can also adjust. Set g 0.1 or 0.01 just to see what happens. And then Vx doesn't change if we don't want to put friction. Otherwise, we can also put the friction with air and so decrease X and Y. Maybe we can do next step. Then if I don't know, X less than max X core, PX core, and Y greater than 0 and Y less than max PY core, or greater than mean PY core, mean PY core, and Y less than this, we can set X core X, set XY, set XY, XY. So otherwise, so we can put in if else. Otherwise, we can check and see. We can say user message for the moment. The ball exited the field, and then say stop. Let okay, but we have to repeat this forever. So while true, for instance, we can do this. Then we check for the rest. So let g times dt check. Okay, I can save. Is no something wrong? No. Okay, so setup, aim, fire. Okay, the ball exited the field. Okay, may I have put the power? No. Yes. Oh yes. Oh. So setup, fire. No, probably the power is not here. Halt. So this is powder times and powder times heading. Probably powder has to be much smaller than this. So let set up it from 0 to 1. Let's see if this now works. So set up. I put less power, fire. Okay. If I increase setup, okay, so this is already a good starting. Now, clearly, we have to check what happens if we are not exiting. So if now p color maybe before we can check if it is if it has hit the ship, but let me say if p color equal blue, we can say user message, and then we can the ball dropped in water. Let me see if it is working. Stop. So let's see. Aim, fire. No. Probably because the T is too large and the the ball traveled outside. Something is not working. Okay. If so, let me inspect this ball. Ball 2, inspect, and maybe not here. I can ask this ball, which is the color of the patch, it is on. So ask one of balls, we have just one, show the color 105, and the colors watching 105 is blue. So something not if the color equal blue, show ok. If the color equal blue, show okay, just to see. Okay, so this is the right condition, but yes, because I haven't put it inside the while. Okay, so now this should okay, the ball dropped in water, and before of this, if any ships in radius 1, then user message you won. Stop. Let me see if this works here. Okay, now. So aim maybe with less powder fire. No. Okay, maybe one is okay. So maybe we can say we have to die when the ball falls into water, so that we can repeat maybe with okay. So you see that with some refinement we can say play with this game. So what do you think? Do you have some other okay, we can make things more complex by letting the ship to travel, if you want. So maybe we can make here a forever loop instead of in the trajectory, so that every time the projectile so proceeds along the trajectory, and also the ship can travel. So maybe we can put here while through, do this instead of here. Let me see if this works for the moment. Aim, fire, okay. So it is working. And so ask balls do trajectory, ask ships move, see, and to sail, say maybe another variable could be the speed of the ship. Say move xy, set x core plus ship speed time dt. So here we can say that the ship's own speed, reality speed, own speed. So when the ship is created, we can set the speed 0.1, 0.2, 0.1. Then this could be a variable. So plus speed times dt. If, say, x core greater than max px core, remember that px core is here, so we should have time to stop the things. So use message you lose and stop, and so ships on. Okay, let me save. Let's see. Setup, aim, fire. Ok. You lose. Okay, halt. You lose, and probably we have to set up some flag. Continue. So to set up, so to fire, set continue true, because if not continue halt or stop. Let me see if it is working at this level. So instead of stop, set continue false. Set continue false. Set continue false. Here not, because we may want to continue to fire again. Maybe the speed of the ship is too much. Okay, let's see. Yeah. Maybe the ship has to be set one Apache with P core, if I do, and PX core less than say world width divided by 3, otherwise it is created. So okay, now it is created in this range. Aim fire too much, too speed, too fast. Okay, so let's speed 0. This fire is not working in this way. We have to use another strategy. Or maybe we can die. Instead of die, we can reset the position of the ball. So let me set up ball, set color, set heading, say this set up ball, set heading of one of cannons, so that this can be called by anybody to okay, I'm almost finished there. So here, let's see, set up ball, set up, and here instead of course set up ball. But not we have to stop set up ball. We have to think to a different strategy. So maybe we can to fire we have to have a different strategy, because instead of doing this, we can make a go button, go button, so that during to go we ask ship sail, okay, to go set continue true, and then I ask a ship to sail, and that's and then if fired, ask if fired, ask balls, do trajectory, and no, this end. Okay, so fired. Okay, this is another flag. So to fire ask cannon all this, and then set fired true. It is false by default. So this is to be removed here. To sail, okay, to do trajectory. Here we can set the fire false. And maybe set up a ball, we can set fire false here. To set up ball, set fire false. Let me see now. And to go and set up fired. So to go, okay, we have to set up also this to set up set fired false. Okay, so to go, the ship is going, and then I can fire. Oops, no. We can for set up to set up a ball, set the heading of one of cannons, set X score. We have to set X score of one of cannons. And to fire. Yes, but I have to die. Okay, no, we have to die. We have to die because fire has cannon to do this. So aim, go, fire. Okay, now this is my. Okay, we have something not working here, but probably we can remove this heading of myself. It should work now. Set up, aim, fire. No. Okay, now you can imagine that there is some refinement to be done in order to have it not working well. This here, set up a ball. Probably I have to come back instead of set up a ball, since it is not really used. I can remove this and re-put it here. Let me hatch ball, set shapes, set the heading of myself, set shape circle, set size. Okay, let me see. Aims, fire, but I don't know why it goes this direction instead of. So this is all true. The problem is ask H set VX powder set fire false. To fire. Okay, this set fire false clearly is not really working. to do trajectory set. Yes, because I have not set x and y. Set x core, set y core. It was already present before. Set up, aim, go, fire. Okay. Maybe let me change. Okay. Something more or less is working. Questions, comments? So
clear so far.
Okay, so I think that for today it is enough. Try to play a bit with these examples, and please let's suggest some theme, something to develop for next lesson. Clearly, otherwise I can continue with say or games or classical things. But clearly, since I am a physicist, I'm more led to propose physical problems, like I don't know how to say to land on the Death Star, or how to destroy the Death Star in Star Wars. I don't remember which one, the Return of the Jedi or something like this. And so please propose something new, and we can see again next Tuesday.
Thank you, Professor.
Don't forget to sign your participation in the form.
Okay, thank you so much.
Thank you.
Bye bye.
Thank you.
Thank you. Bye bye.
Thank you. Bye.
Thank you. Bye bye.
Thank you.
Thank you. Bye.
Bye.